Hello everyone, welcome to my new video. I am Nafiz Rahman Shomik. Today I will present the topic of research methodology, a new topic of research methodology. My topic is regression model with two explanatory variables. Here are some subtopics. The general model, RSS, OLS, and goodness of fit and ANOVA, and the matrix formulation of multiple regression. Now, the first question is regression model with two explanatory variable. What is the regression model with two explanatory variable? In i- this topic, we uh, a single linear regression model where uh, yeah, dependent variable are depends on one single variable, but in the two explanatory variable regression model with two explanatory variable, dependent variable are depends on two or more independent variable. Here are the general model. The general model for the two explanatory variable is y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and mu. Here y is the dependent variable and x1 and x2 is the independent variable. Beta 1, beta 2 and beta naught is the regression coefficient and mu is the error term. Okay. If you using the sample data, y hat is equal to b naught plus b1 x1 plus b2 x2 plus e. Here b1, b2 and b3 is the coefficient. Now we can move the next topic is the RSS. RSS measures the difference between actual and predicted variable. RSS is equal to summation of y minus y hat whole square. Here here we put the value of y hat, which is beta naught beta naught or beta 1 x1 beta 2 x2 square. Minimizing the RSS ensure the best possible fit of the regression line of the rest regression line. Now we move the next topic, OLS. Here OLS estimators regress the coefficient by minimizing RSS. The normal equation used to solve the beta naught, beta one, b naught, b1 and b2. OLS minimize the RSS. RSS is equal to summation of y1 yi minus beta naught beta 1 x1 I beta 2 x1 x2 I2 whole square. If we partially derivative the set and and put the value is equal to 0, the first order condition, beta naught we can write beta naught is equal to y summation of y n beta naught plus beta 1 summation of x1 plus beta 2 summation of x2. For v1 we can write summation of x1 y is equal to beta naught summation of x1 beta 1 summation of x1 square plus beta 2 summation of x1 into x2. And for beta 2, oh sorry, b2, for v2 we can write x2 summation of x2y is equal to beta naught summation of x2 plus beta 1 summation of x1 into x2 plus beta 2 summation of x2 square. Now, solving the equation, we can write beta 1 is equal to summation of y into x1 into summation of x2 square minus y into x2 summation of x1 into x2 divided by x1 square in summation of x1 square into x2 square minus x1 x2 whole square, and beta 2 we can write beta 2 is equal to summation of y x2 into summation of x1 square minus summation of y x1 into summation of x1 x2 divided by summation of x1 square into summation of x2 square minus summation of x1 x2 whole square, and the inter intercept b naught is equal to y hat minus beta 1 x1 into beta 2 x2. Now we can move our next slide. Here is the goodness of fit. The goodness of fit, mm, the goodness of fit and ANOVA. The goodness coefficient is determined by R square. R square is equal to ESS divided by TSS. Here ESS is the TSS is the total sum square, and ESS is the explanatory sum square, and RSS is the residual sum square. Okay, here we can write r square is also 1 minus RSS by TSS. Okay, if the value of RSS is equal to 1, it is perfectly fit, and if the value of r square is equal to 0 is not explanatory power. The higher r square means the better fit, but adding the va- adding the variables always increase r square. Okay, we can now move our next slide. Here r square is equal to 1 minus 1 minus 1 r r head square is equal to 1 minus 1 minus 1 minus r square into 1 n minus 1 divided by n minus k. Here n is equal to number of observation and k is equal to number of parameter. ANOVA. ANOVA here ANOVA decomposes the total value TSS. TSS is equal to ESS plus RSS. Okay, we can now move our next slide. The F test. Uh, F here the test, if the at least mm, one predictor has the significant impact, we can write our null hypothesis a is not is equal to all regressor coefficient are 0, where f is equal to r square divided by 1 minus k minus 1 divided by 1 minus r square is r square divided by n minus k. Now we can move our next topic, which is matrix formula of multiple regression. We can write for a general k variable model, we can write y is equal to x beta plus u. Here y is equal to n into 1 vector dependent variable matrix, and x is equal to n into k matrix on of independent variable. Beta is equal to k into 1 vector coefficient, and u is equal to n into 1 vector errors. Here the OLS estimator beta, we can write beta hat is equal to x dash into x whole inverse into x dash y. Now we can move a maximum likelihood estimators MLE. Here MLE L likelihood function L is equal to um, theta by y is equal to function of y by theta is equal to pi I to n 1 divided by twice pi sigma square e to the power minus yi minus xi beta whole square divided by 2 into sigma square. Taking the log likelihood function, uh, L beta sigma square is equal to minus n divided by 2 log twice pi minus twice pi n divided by 2 log sigma square minus 1 divided by twice sigma square, uh, summation of y minus x beta whole square, where MLE estimator solve delta L by delta theta is equal to 0. Now we can move some important topic of statistics. Oh. We can move the sorry mm, maximum likelihood estimator MSE. The key properties of OLS and MSE here, uh, est- uh, expected value of beta hat is equal to beta. Uh, the efficiency has too low variance among the linear estimator. The normality beta hat is equal to normal beta uh, sigma square x bar x dash into x whole inverse, and the properties of MLE estimator is P of sigma theta hat is equal to theta, normal theta hat is equal to normal theta L minus 1 theta, and the efficiency MLE achieve the lowest vari- variance in large samples. Here is the our last topic and the some important topic of uh, statistics concept, the multicollinearity, heteroscedasticity, and autocollinearity. Sorry, autocorrelation. Okay. And that's for all from my for today. We can see everyone in our next video. Thank you for all.